For this video, we are going to go through your section B of your LAB 6.1, which is actually a prelim practice. So for your section B is basically your typical full experiment where you need to do table, graph, source of error. So it's very standard. So most of the time, O-level will usually put one electrical experiment in it. But I remember when you are doing this, you have not learned electricity. So I have given you the reading. Okay, so whenever I just want to highlight some of the things. Whenever you are given a ruler and then you need to move your jockey over, right, you should try to maximize your range. Meaning that out of the 5 reading, try to cover between 10 cm all the way till your 90 cm. In some experiment, they will tell you, hey, please limit your range to 10 to 40, then you follow. But if there is no limitation of your range, you try to maximize it. So it is okay in your table that you have irregular interval. For example, you can do 10, 30, then maybe this one is 60, then 70, and then 90. It's fine. Okay, as long as you cover 10 to 90, it will be good. Okay, so let's take a quick look. So for voltmeter, 2 dp, and unit is V. So I remember this one is I give you the dummy reading, so I think it is fine. So for here, you should give me 2 dp in V, you will get back your 1 point. And then for your A, I'm quite sure I give you the dummy value. I'm not sure whether you do it yourself, but it should be 2 dp. So you get 1. Then after that, you are supposed to take 1 over L. In this case, I think L given to you is 50 cm. But because you are using your meter ruler, so when you are using your meter ruler, the precision of your 50 cm will become 50.0 cm, and you should carry this into your question here. So this one is wrong. It should be 1 over 50.0. For this particular operation, is the same as this. So you have to follow least SF rule. So you should give me an answer that is in 3SF, because 1SF, 2SF, 3SF. Okay, so down here this is wrong. It should be 3SF. Unit is correct, calculation is correct. So correct calculation, unfortunately this is wrong, correct unit. So I think you will get 1 mark. Let's look at the table. Good. Yeah, so you see, this FF. So correct, because 1 dp. Correct, 2 dp. This one, I will check this. So this is wrong, should be 3SF. This one is wrong because this guy here is 3SF. So cha. What a waste. So let's go here. 5 sets of data. Look at the trend. L go up, I go down. Right? Let's see. L go up, I go down. So correct trend. LIA correct unit. All values correct. Range of L satisfied because range of L is 30 is your smallest, 90 is your biggest. So you have a range of 60. So I think it's correct. Unfortunately, this is wasted. So 4. Okay, let's look at her graph. She's supposed to plot I against 1 over L. So this should be my y-axis. This should be my x-axis. So correct and correct unit. Correct axis, correct unit. After that, these are her points. So I will look at her spread first. So looking at this, I can see that on the y direction, she has already occupied 50%. If I look at the x direction, which is here to here, So in the X direction, she has also occupied 50%. So I would say the scale was chosen, should be chosen correctly. So let's take a closer look. So one very obvious error is here. I think what she meant is 0.005. Yeah, if not, you will end up with irregular interval. The y-axis looks good. So I think the y-axis she will get the mark, but the x-axis, unfortunately, due to this error, she won't get the full mark. So the next thing is that I will check her precision. So looking at, I think this part here, she is doing her precision calculation of each axis. One glaring error is this. You shouldn't be dividing by 25, it should be divided by 20, because you are reading to half the smallest. So what happened is that from this point to this point, there are 10 tiny squares, but you are going to read till half the smallest square. So as a result, you are actually having an interval of, for example, if I'm calculating the x-axis precision, I would have from 0 to 0.05, and I will divide it by 20 tiny square. Okay, so as a result, I should get an answer like 0.00025. And what does this tell us? This tells us that this is the smallest reading you can get from your x-axis scale. So as a result, your x-axis, your coordinate x-axis will have a precision of 5 dp. 1, 2, 3, 4, 5 dp. Now if you do the same thing for your y-axis, you can see that it is an interval of 0.10 to 0 divided by 20 tiny square, and you will get the answer 0.005, and this tells you that this is my smallest y-axis reading. So as a result, I will get a precision of 3 dp. Okay, so down here by luck, the y-axis precision is correct, but unfortunately the x-axis here will be wrong. So if I look at her coordinate, so if I blow it up, so that's why it is important for you to write this big. So this is what she wrote. Okay, and this is what she wrote. So if I were to mark, then this will be correct, but unfortunately this one and this one will be wrong. It should be 5 dp. Okay, so because of this one error, I would expect her gradient to be wrong as well, because this should be 0.03100 minus 0.01500. So if you look at all these numbers, you will see that your gradient should have a least SF of 3SF. So as a result, this is wrong. Now one more thing, what she has done here is that she has actually found the gradient, right? But the question actually wants her to find K. So what is K? So now if you scroll up and you look at this equation here, you will see that by comparing coefficient, your gradient, okay, your gradient is actually at the same position of V over K. So what does it mean? It means that your gradient is equals to V over K. So if you want to find K, it is just V over gradient. So I think for her, she didn't do that step. So down here, she will be wrong as well. Okay, so let's take a look. How would we grade her? So down here, axis labeled correctly with the correct unit. Scale marking is every 2 cm, but it is not a suitable scale because her scale is wrong. Why wrong? Down here, this guy. Okay. So she will lose that 1 mark over here. She start with the origin. It is not weird. You just need to cover 50% or more. So she will get this mark also. She only lose this part. All points are plotted correctly. I didn't check for this purpose, but in exam we will check. Best fit line, definitely. If you look at her line, it is very nice. Okay, there's positive error, negative error. It passes through as many points as possible. There's no better way to draw it. So as a result, this one she will get. So she will get about 3 marks. She has identified two coordinates and read them correctly. She has used a triangle that is big enough, so she will get 0.5 over here. Calculation of gradient is correct. She used the correct formula y over x. However, the input data is not read to half the smallest, so meaning that the precision is wrong. And of course, because of that, the answer will have a wrong significant figure. So as a result, she only get 0.5 over here. And obviously, she didn't notice that the question actually wants her to find k rather than the gradient, so she will get 0. So let's continue. So now the question wants you to find the y-intercept followed by finding this fixed resistor R. So what happened is that you notice that for her graph, if you were to use the graph to find the y-intercept will be actually below the graph. So you cannot read directly from the graph. But if you have a line that looks like that, you can read directly over here, and you just need to label out your coordinate following the correct precision of the coordinates. Yeah, so for here you cannot read from the graph, so what do? You have to find by substitution. So looking at her reading, I realized that I do not know where she get these two reading, so this will be wrong. What I suggest you to do is that you can just use either this reading or this reading, up to you. Okay, so for me, I will just use the bottom one. So let me just write it here. I will just sub 0.01500. You need to write with the precision. Okay, in theory paper you don't need, but in practical paper definitely. So down here it should be 0.01500. Here should be 0.260, and because of the previous error over here, it leads to this guy also having the wrong SF. It should be 3SF. So if you look at the precision of each of the data over here, you will see that your C, okay, should be 3SF as well. That is your least SF. And your job is to find R. So what happened is that if you look at here, your y-intercept is actually corresponding to this. So in a certain way, your y-intercept is equals to V over R. So to find R, it is just V over the y-intercept. So as a result, down here, she did it right this time round. Yeah. C equals to V over R, but unfortunately this would be 3SF. Okay, so as a result, this should also be 3SF. Okay, so anyway, we'll come back to these two questions after we finish DC circuit, which is in the next chapter. So let's see how many marks you will get. Down here, determine the y-intercept, correct. Record it with the correct precision. So unfortunately, by calculation, she got the wrong precision, so I couldn't give the mark to her. So down here, most likely she will get 0.5 or even 0, but she managed to equate it, so very good. Okay, I should end here. So remember, please do the marking, do the correction on your marking sheet. I want to see the ticks at the right place. I want to see marks assigned. For your question 2D, do it yourself, mark first. I will look at it and I will give you the